So today we're going to discuss the unit on water systems. There are 5 characteristics of water, those being polarity, hydrogen bonding, cohesion, adhesion, and heat capacity. Polarity means that water is electrically charged. The oxygen atoms carry negative charges, and the hydrogen atoms carry positive charges. These atoms are bonded together, forming H2O, which is a chemical symbol for water. Polar molecules that have both positive and negative ends that are attracted to each other and stick together are called cohesive molecules. Molecules that stick to other things are adhesive molecules. Examples of adhesion are water droplets that stick to spider webs or water droplets that stick to blades of grass. Now, water holds heat longer relative to land, and it slowly releases that heat, allowing for the climate around those large bodies of water to be warmer. So if you are in the coastal areas of Virginia during the fall and winter, that area is going to be warmer because the Atlantic Ocean is slowly releasing the heat that it gained all summer long. That tells us that water has a higher specific heat capacity than land does. Another characteristic of water is surface tension. Surface tension is the tightness across the surface of the water. This is caused by those polar molecules pulling at each other. And this is what allows insects like the water strider to walk on water. See how he's appearing to walk on water? It's because these polar molecules are sticking together and his body cannot penetrate that bond. This also allows water to form into round beads. Now, with water, there's physical weathering and chemical weathering. Physical weathering is the breaking up and the grinding down of rocks, as well as it's the type of weathering when water freezes and expands and then it breaks up that rock into small pebbles. This is a good picture depicting physical weathering. Over time, water has worn down these rocks into various shapes. Chemical weathering is the process of water dissolving the minerals in rocks, as well as when acid rain discolors a marble statue. So this statue is being discolored because of the rain that is wearing away the natural chemicals in the rock. Let's talk about water's occurrence on our Earth. Earth is about 4.5 to 5 billion years old, and water came to be on Earth through condensation in the water cycle. Now 97% of our water is salt water, and that can be found in our oceans. 3%, around 3% of that water is fresh water, and those are located in lakes, rivers, streams, and aquifers. So that leaves us with less than 1% of our water being fresh water, which is available for human consumption. Water can be found in oceans, lakes, and in living things, and that accounts for all of our water on Earth. If you were to look closely at this picture, this large marble represents the 97% of salt water that's on Earth. The smaller marble represents less than 3% of fresh water. And then right behind the letter C here is a blue dot that represents the less than 1% of water that we can drink. People and water. An artificial pond or lake that's used to store water is called a reservoir. This is usually a man-made lake that a community has in order to hold water and release it when it's needed. Irrigation is the process of supplying water to areas of land to make them more suitable for growing crops. So there's some areas and in the farm and deserts where we have to irrigate water because they don't get enough. Electricity created from water's kinetic energy is called hydroelectricity, and power produced by water flowing over a dam and turning a turbine is called hydroelectric power. Hydroelectric power is used as a renewable form of energy, and it's very necessary in some areas of our country. Using a resource wisely so it won't be used up is called conservation. We all need to conserve our resources so that they won't run out for future generations. One way we guarantee that our water is free of pollutants is through the use of water treatment plants in sanitary sewers. Water treatment plants filter used water and recycle it so that it can be used again. And sanitary sewers take that water that cannot be used again and it discards of it. Now, in our earth, there are areas called wetlands and estuaries. And these areas are very important for our ecosystems. An ecosystem is made up of biotic communities, which are living, and abiotic communities, which are non-living factors. The health of an ecosystem is directly related to water quality. Wetlands are natural sponges. They store water during wet periods and they add water to streams and rivers during dry times. They have special soils that hold the water for long periods of time. And therefore, wetlands form a transition zone between dry land and certain bodies of water. Wetlands also aid in flood control. They slow down the flow of water, regulating runoff, and they store water that is usually flooded. Wetlands are also important for erosion control. Wetlands tend to slow down the water, which decreases erosion of our land. Once it hits the grasses, that water seems to slow down and not cause the sand or the land to wear away as fast. Wetlands are also natural filters. They trap in sediments and unwanted things such as debris and pollution in our waters, and they maintain the water quality by filtering sediments and trapping these nutrients and breaking down pollution, and it recharges our groundwater. Wetlands are also habitats for wildlife. They serve as homes for our birds and aquatic organisms. Wetlands provide food and nutrients and shelter for birds that are migrating or nesting. And they provide habitats for many organisms and serve as nurseries for their young. Now, these nurseries provide water, oxygen, and land for animals to reproduce. They also provide food and shelter for wildlife and fishing, and resting areas for migratory birds. Wetlands have a vegetation that can tolerate being underwater for certain periods of time. So these plants live in these areas where they may not be able to live and survive in other areas. And there is a human impact to our wetlands. Wetlands are very sensitive to what humans do, and recently people have started to fill in the swamps and build on top of wetlands. So the government has decided to provide agencies that protect and restore our wetlands for the sake of animals and land preservation. Now we're going to look at the water cycle. If you look at this graphic, you should remember the process of the water cycle. Here's a word bank at the bottom of the page. I want to stop the tape now and allow you some time to fill in these blanks. See if you and a neighbor can work on putting the correct words in the correct spot. Stop the tape now. Okay, so if you have filled in these blanks, now let's check them to see if you are correct. Condensation occurs here in our clouds. Transpiration occurs in the leaves of plants and trees. Collection is any body of water that has collected in a certain area. Groundwater is the water that is under our ground. That groundwater may be in an aquifer, or that groundwater may run and pool into a collection. Runoff is the water that hits the surface of our earth and runs off. It does not get absorbed into the ground. Precipitation is rain, snow, sleet, or hail, and that falls from the clouds. Evaporation is water that is evaporating up into the sky due to thermal energy from the sun. And infiltration is any water that actually gets absorbed into the ground and it infiltrates the layers of the ground and it eventually becomes groundwater. Watersheds. A watershed is an area of land where all of the water that is under it drains off of it and it goes into the same place. So this picture shows a watershed. At the top, after precipitation falls, or maybe there is some snow melt, there is what we call headwaters. Headwaters is the beginning of any drainage area. You might have wetlands in that area where vegetation is growing. You might have tributaries that connect and lead into this forming river. You might have a floodplain where there's more water than the land can hold, and so that water floods over onto the land. And as you come down this watershed, it eventually either goes into the ground or enters a larger body of water. So this is a good example of a watershed, an area where all the water drains into. The Chesapeake Bay watershed, which is partly in Virginia, it stretches across more than 64,000 square miles, and it involves 6 different states: Delaware, Maryland, New York, Pennsylvania, Virginia, West Virginia, and all of Washington, D.C. The Chesapeake Bay watershed consists of more than 100,000 streams and rivers. These are called tributaries because they eventually flow into a larger body of water. The Chesapeake Bay is also the largest estuary in the United States. An estuary is a partially enclosed body of water along any coast where fresh water from the rivers and streams meet up and mix with the salt water from the ocean. That mixed water is known as brackish water. Now we're going to talk about our solar system. This is our Earth and Space unit. A couple of things that we need to understand about the solar system. The solar system consists of the sun, the moon, the earth, other planets and their moons, meteors, asteroids, and comets. The distance between planets and the sizes of these planets vary greatly. The outer planets are called gas giants or Jovian planets, and they're very large. And then you have the inner planets, and they're called terrestrial planets because they're smaller and they're rocky. Gravity is a force that keeps the planets in motion around the sun. Gravity acts everywhere in our universe, so don't believe it when people say there's no gravity in space. It's just less dense than gravity anywhere else. Planets revolve around the sun, and moons revolve around planets. A planet solely rotates on an axis. So you may have a planet that's spinning on its own axis, but also revolving around a larger body. A dwarf planet revolves around the sun, and it can maintain a nearly round shape, but it cannot move other objects away from its orbital neighborhood. Dwarf planets are much smaller than regular planets, and some of them are even smaller than moons. As Earth rotates, different sides of the Earth face toward or away from the sun. This causes day and night. The phases of the moon are caused by its position relative to the Earth and the sun. So Wherever the moon ends up facing, that's what causes the phases of the moon. Earth is a rocky planet, and it's extensively covered with large oceans of liquid water, and it has frozen ice caps in its polar regions. Earth has a protective atmosphere consisting predominantly of nitrogen and oxygen, and it has a magnetic field. The atmosphere and the magnetic field help shield Earth's surface from harmful solar radiation. Our Earth is about 4.5 to 5 billion years old. Now, what causes seasons? Seasons are caused by a combination of the tilt of Earth on its axis, the curvature of Earth's surface, that's how it's shaped, and the angle at which sunlight strikes the surface of the Earth during its revolution around the sun. What causes tides? Tides are the result of the gravitational pull of the moon and the sun on the surface waters of our Earth. There are spring tides and neap tides. Spring tides are aligned or caused when the sun, the earth, and the moon are aligned in 180-degree angles. And neap tides are caused by the sun and the earth and the moon being angled at 90 degrees. Now, some early philosophers and astronomers had a say and an understanding about our solar system. These people that go by the names of Ptolemy, Aristotle, Copernicus, Galileo, and Kepler helped us to understand the solar system. So now I want you to stop the tape and answer these questions with a neighbor at your table and see who gets the most questions correct. There are 11 questions here. See if you can answer them. You can stop the tape now. So now let's answer the questions. Number 1, there are 8 planets in our solar system. Even though recently there have been a total of 7 new planets identified, but they're yet unnamed. Number 2, planets in the solar system rotate right to left or counterclockwise. List the inner planets. You should have said Mercury, Venus, Earth, and Mars. Number 4, another name for the inner planets are the terrestrial planets. Number 5, the outer planets are Jupiter, Saturn, Uranus, and Neptune. And another name for the outer planets are the gas giants or Jovian planets. Number 7, gravity and inertia keep our planets orbiting around the sun. Gravity is the attraction or the pull between any two objects, and inertia is the tendency of a thing to resist a change in motion or rest. Any natural or artificial object that orbits Earth is called a satellite. So even our moon is a satellite. It is a natural satellite, and then there are man-made satellites that we have placed in our atmosphere. And lastly, if you were to list each planet in order by distance from the sun, you should have stated Mercury, Venus, Earth, and Mars, Jupiter, Saturn, Uranus, and Neptune. And give yourself extra points if you listed the acronym, My Very Educated Mother Just Served Us Nachos. Now, here's another opportunity for another table to win a prize or points. Stop the tape so that you can answer these questions, and then we'll come back with the answer. Now, if you have finished answering these questions, here are the answers to days, years, and seasons. When Earth spins on an axis, this is called a rotation. When Earth goes around the Sun, this is called a revolution. It takes Earth 365 days, or 1 year, to revolve around the Sun. It takes the Moon 30 days, or a month, to revolve around Earth. February is the month that gets an extra day when we have a leap year. Now, what causes day and night? Earth's rotation on its axis. Number 7, an equinox occurs in which 2 seasons? Those seasons would be spring and fall. A vernal equinox occurs in the spring, and an autumnal equinox occurs in the fall or autumn. A solstice occurs in summer and winter. And in the northern hemisphere, June has the longest day of the year, while December has the shortest day of the year. Here's another challenge regarding space exploration. Give yourselves time to answer this and then restart the tape for the answers. Space exploration. Ptolemy believed in the geocentric model and thought that the planets orbit the Earth in a circular shape. Galileo believed in the geocentric model and thought that the planets orbit the Earth in an elliptical shape. Copernicus believed in the heliocentric model and thought that the planets orbit the Sun in a circular shape. Kepler believed in the heliocentric model and proved that the planets orbit in an elliptical shape around the Sun. Neil Armstrong was the first man to set foot on the moon, and the Soviet Union was the first nation to send a human into orbit and launch a satellite. Skylab and the International Space Station are the names of the space stations. This is the last table challenge that we're going to have, so stop the tape so that you and your table mates can answer these questions. So if you use these hints, it should have helped you to identify these various phases of the moon. The first quarter and last quarter moon look like semicircles. So the first quarter moon is here, and the last quarter moon is here. The smallest shape of the moon is called a crescent. These are crescent shapes here. The largest shape of the moon is a full moon, where you can fully see the sun. The moon phase in which 3/4 of the moon is lit is also known as a gibbous moon. More than half of the moon is lit here. So these are known as gibbous moons. Waxing means that the light is growing. It starts off small here, gets bigger and bigger until it's full. Waning means that the light is fading. It's less than full. It's a quarter moon here, and then it's a crescent shape. So the light is waning until there's no light on the moon at all. So you should have labeled this the new moon, first quarter. Waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, and waning crescent. During the springtide, the 180-degree position of the sun, moon, and earth cause high tides and low tides. During a neap tide, the 90-degree position of the sun, moon, and earth cause lower high tides and slightly higher low tides. Best wishes on your 8th grade SOL.